Hello, and my name is Janet, and this is my presentation for assignment 3, whereby we'll be presenting a smart light solution app, the design, deployment, and functionality of the application with getting the Azure as the Microsoft Azure as the provider of choice, and created an IoT hub. And inside the hub, this is to containerize all things pertaining the IoT. And also, we're going to receive some messages through here. So we went to first creating the IoT hub, assigned it to a resource group, and then added a device. The first device was added via this Azure portal, but the other two devices were added via the Node-RED. So the connection string that we got from the IoT hub owner. So to access the security settings to get the identity and access management, we go through to security settings, go to the shared access policies, whereby on the IoT hub owner, we get the credentials that we require for the connection string, and also basically the connection string that you're going to use to connect in the Node-RED will be used to create the other two devices which I'd already created, but the process was I used an inject node and an IoT hub registry node. And in this IoT hub registry node, the connection string from the IoT hub owner is what is going to be used in this. So we've done that, and we've already shown that we have two devices that are created via the Node-RED. For the inject node, we added the message payload and changed this into JSON and just put in data inside there, and then as an object. So we put the relevant information that was required in the inject node and then connected this to the Azure IoT Hub registry. Once you trigger the inject, it is going to deploy, and it's basically going to deploy the smart light solution device on the IoT hub. So when you go back to the IoT hub, you'll manage to see that we've added two more devices, and that is the smart light solution 2 and smart light solution 3, which are both enabled. So back to the Azure portal, we created a container. We were going to use this container for, we were going to use the username and the password. This is going to be useful, especially when you're doing the Docker login to the container registry. Create a Node-RED file using the Azure CLI. So we used bash and then put in the command echo from docker io /node-red /node-red create node-red, and that created a file. We're going to use that, and we're going to push it into the repositories of the container registry. So to do that, we use the command line, that is the cmd, and we were to put in the command docker login and then use this server, that is the container for Smart Light Solution Server, and use the password, that is the username and password provided here. So once that's done, we can go back to our command again and put in the Docker pull, tag, and push commands. However, in my case, that wasn't successful. Therefore, I had to build using Git. They were not functional since they were empty and they were corrupted files. You can use the container registry to check. So once that is done, it should show Node-RED has been added. And through this, we deployed our web application. We deployed this, and then we worked on our workflow through the Node-RED. So the nodes were added individually, and I used an inject node whereby the inject node was configured with a payload of data turn on. This is of type JSON. This was an error before, but once it was corrected to JSON, we managed to have communication. Then we put two nodes to trigger or to simulate sensors. One is sunset and the other one is midnight. So sunset has the same type of payload but says data turn off. Sorry, midnight. And then we generated a custom and created a custom message whereby it just says the message topic, which is the devices. If sunset, we put some if statement. If it's sunset, return turn on the lights, but else if it is midnight, turn the lights off. So when the message goes through, when the payload goes through the function, the output is turn on. And when it goes through the midnight, the output is turn off. To connect to our IoT hub, we used the MQTT out, and this was configured to the server. So it's connecting to the smart light solution .azure.devicenet server through port 8883. And we configured to use the TLS, and the client ID is similar to Smart Light Solution 1. So these two are working for one light solution. For security, we used the username that was created and a password that was generated using the Azure CLI using this command. Using this command on the bash shell, we managed to generate our SAS. That is the token that was used to create, was used as a password for the MQTT broker node. So that allows us to connect to the IoT server. So events and triggers that are happening on the node red can be viewed under the IoT hub metrics or the metrics panel, or right here is where we can see what is happening. We can see how many messages were used today, how many IoT devices that we have, the messages that were sent, when they were sent, and it can show you the activity of the devices and when they peaked, so the downtime and how they're performing. So this is important, especially at scale, because it gives the managers or the developers the ability to manage their devices and see the devices and how they are working, and also predict like maintenance and schedule. They can also predict the costs. They can predict usage of the devices to predict if they need to scale up or scale down. So you can see using the, we picked one of the metrics, which was messages, a visual representation of how the three devices have been performing. In a real world scenario, this would probably be many messages since it is ongoing. However, by adjusting that, and it can deploy every 30 seconds, it can send a message every 30 seconds. Therefore, we can visualize this in real time on the metrics panel. So we had 12 messages. We've set the node red to send every 10 seconds. So we were at 12. Once we hit the refresh, we'll see that we have more messages coming in every 5 seconds. So we can see through this panel, this is the debug panel, that messages are coming in after every 5 seconds for the sunset and every 10 seconds for the midnight turn off. So we can view this on the metrics and view the messages going in. We just refresh. We can see it keeps on changing to show active connection. Through the IoT hub, one can further check for alerts. Diagnostic settings can be configured where you can make any settings for the following features. You can check logs and query logs. This is important, especially for this particular business in terms of scaling and in terms of checking viability of the business in terms of costs and seeing the devices and managing the devices remotely. That concludes my presentation on the Node-RED Azure IoT integration for the smart light solution.